Welcome to Geology, everybody. Let's look at some of Chapter 8. I don't want to do all of it because it's too much to talk about. I don't know. I really like this stuff. So let's just do weathering today. Maybe a little bit of thought about sediment. Soil we're going to save for a future video. I'll throw this into that document as well if you want to use it. Your call. All exposed bits of earth are constantly under attack. They're constantly being beat up. And so to understand this, we're looking at the processes of weathering, erosion, and deposition. All right. It's brutal for rock at Earth's surface, but you got to think of it not on human timescales. Think of it on geological timescales. You know, there's exposed bedrock on campus, for example, down by the president's house and Riggs and Johnson down there, right? If you go down on the lakeshore there, you see exposed bedrock. That is constantly under, that's at a really interesting point because it's between the atmosphere, the hydrosphere, Lake Ontario, and the bedrock itself in the land, right? At that little triple point, it's constantly under attack. It's being beat up. It's being broken down into smaller bits. That's what this weathering idea is going to be. So really, if we wanted to make this in like simple terms so that we understand what these really mean, weathering is like the breakdown of bedrock. So take that exposed bedrock that's there, that's old, and break it up, break it into pieces through these processes that we're going to talk about in a minute. Distinctly from that, erosion, we could think about that more in the sense of like the transportation of those broken down bits, which leads us to, hey, maybe we should have a name for that. So when weathering happens, it breaks down bedrock into sediments. And then the erosion is like the transportation of those sediments. And then finally, the deposition is like the drop off of those sediments, which happens in fairly organized bits. But again, let's worry about that another time and really just start to look at how Earth's bedrock is under constant, relentless attack because of the nature of the atmosphere and the hydrosphere. So we've got two basic kinds of weathering that we're going to categorize them all into one of these two. The first one I've heard called both physical or mechanical. And we got a couple of different kinds. Your book does some in decent detail too. We'll pop over and look at that a little bit as well. They go mechanical, so we'll go mechanical weathering instead of physical. How about that? So what are they? Let's do the easy ones first, easier ones. I think the easiest is, and I understand these graphics are not super hot, but roll with me. These are fairly easy ideas. I think the easiest one to see is root wedging. Ever seen? That's spelled wrong. Have you ever seen a like dandelion pop through a sidewalk? You know what I mean? As it turns out, plant roots are pretty strong. Or you can see where a tree root goes underneath the sidewalk and like buckles it right up. The ability of these roots is crazy in terms of its strength. So if a plant starts to develop somewhere, in fact, I've got pictures down here of all this stuff. Here's one that I took down in the, this is that state park that's down south of Auburn. Is it Fillmore? Where a plant started to grow here, you can see these young roots sticking out and trying to find little cracks in the rock. If this thing gets bigger and bigger and bigger and bigger, those roots get into those cracks, find the joint sets, find the like layering bedding planes, and wiggle their way into that slowly, but through time can crack open the rock. Along with that is this idea, and if you're a New Yorker, which I know most of us are, this is the reason why our highways, particularly upstate where there's more transitions between freezing and thawing, are so bad. Water expands when it freezes. We should make a note of that. That's kind of a key part of this. Water expands when it freezes. Smaller. I think a lot of people know this. If you leave a water bottle in the freezer, you experience it. If you leave like a soda can, it can explode. So have water seep into the crack of a rock or into the crack of a highway, and then have it freeze. And when it freezes, it expands and wedges open the rock a little bit more. And then if it melts and then it freezes again, that happens over and over again. So in climates where you get a lot of transitions freezing, melting, freezing, melting, freezing, melting, you're going to get more of this. The ocean downstate, I think, prevents as many of those transitions. You stay a little bit warmer thanks to the ocean, but upstate, this is certainly why our highways are so banged up. So those two are similar in nature, right? They're both some form of wedging. So back to my pictures, which are down here. Well, there's root wedging right there. This is in the Adirondacks, down towards the bottom of the Wolf Jaws, if anybody's hiked those. I saw this is years ago. But clearly what happened here, this tree landed as a sapling grew, and its roots have gone down for more nutrients and water, and as it's done, it shoved these two pretty good-sized boulders right apart over the course of the lifespan of this tree, which isn't necessarily geological time. It's pretty short compared to geology. What else? Like this section right here, these two are from the same state park, and you can see right here where like the yellow is, that's probably where this stuff was. Like this is a pretty fresh fall when we came down there. It was springtime when I made this trip. So maybe we could say, yeah, it was ice wedging. It was that water was seeping in along those like predefined joints and expanding and eventually just wedged this out. Maybe there was some root wedging that happened along with it. They can kind of work together to weather away the rock. Again, backing up, we're talking about the breakdown of rock and turning it into sediments, turning into smaller and smaller and smaller bits of rock. What else? Your book really liked this one, the unloading or exfoliation. So here's the idea. Take arbitrary measurement, this circle of rock, right? Back in the age of dinosaurs. And then have, through these processes, have the top get worn away so that this is exposed. Well, this used to be under all this pressure, and now that's not there, which allows this to expand a little bit, but it's rigid. So when it expands, it breaks along, they say both, expansion or exfoliation. An exfoliant on your skin would be like something you rub in, it's kind of gritty to take out the outer layers of the skin. It's kind of the same root. The outer layers of the rock will like slide right off because the unloaded body is able to expand a little bit, but it's rock, it's hard, it's rigid, so it breaks like that. There's a more zoomed out picture of it. And then I've got it from when I went to Rocky Mountain National Park right there. Same idea. All right, and you can see, I mean, with these like, I know this is maybe tricky to see if you're a rookie here, but with these like arch-shaped joints I see on it, it's those would have been like where rock slid right off. What else? Temperature change can do it, like in areas with huge temperature swings, like deserts, get very hot during the day, very cold during the night. So it can almost do this same effect. It can just kind of crumble the outside because of the rock expanding a bit during the day and contracting at night, and doing that daily can break down the outside layer of the rock. I'm not sure I've ever seen that in person, but I've also never really been to the desert. So maybe so, maybe not. And I didn't put the, let me pause and pop up one other picture. Give me one moment. Yep. So here's, this is near where I lived in Colorado. Maybe that. I always in my head was that this was very intense frost wedging. It's all rock that belongs on top of this. This is a small mountain, very easy. You can drive up most of it and climb up the rest. But all made of that bedrock of that mountain, but all completely shattered on the outside. Some freeze thaw, and maybe some of that heating and cooling, because it was reasonably dry here with some pretty good temperature swings. Somebody built some chairs out of it. It was a nice place to hang out. There's more root wedging. This is up in the Superior Trail in northern Minnesota. I noticed it. There's this little tree struggling to grow. Very hard, very old rock here. And it shot a root all the way out, and probably some dropping straight down, very slowly trying to work its way into this extremely hard rock to weather it. But hey, it's breaking it apart. It's root wedging. And then another very cool spot. This is a little closer to home. It's called Hickory Run State Park. If you ever got to go to Philly on the Northeast Extension, it's right off the highway there. You get off, you go to Hickory Run State Park. It's a super cool spot. The bedrock here during the last ice age was completely shattered by freeze thaw. So this like field of boulders, like multiple football fields, just huge. And like, I don't know, 10, 15 feet deep, all just boulders, everywhere you looked. All the same stuff, like all the surround the native bedrock that's there, but pulverized by these freeze-thaw processes. So, with all that babbling, what are we talking here? Physical or mechanical weatherings are a way that, I struggle to not use the word physical in the definition, but the rock is physically being broken into smaller pieces, whether that be through roots, freezing, unloading, any of this stuff, right? The other way that rock can get broken down is chemical weathering. Dissolving is like the easiest one of these to picture. Things that are soluble, and that might be a vocab word that pops up here and there. So let's check it on there. Soluble is the term for like it can dissolve, able to dissolve. Not a very technical sounding definition, but it'll work. Take something that's soluble, like limestone is, in especially in acidic water, and rain is naturally weakly acidic. And when rain hits it and builds up in a stream or collects in a pool, it may work its way down, dissolving as it goes. Eventually, can build cave systems as well. And you know what I should pick here is, sorry, I keep going to having this pop in my head. Let me go grab another picture. So here's Clark's Reservation State Park. Highly recommended, just south of Syracuse. The joint sets in the limestone here, everything's gotten kind of wider gaps and kind of rounded off a little bit. Got a couple other here. This is part of the trail. Look how wide these little gaps are getting. I mean, you got to be, it's not dangerous, but you got to be slightly careful when you hike here because of these big gaps. That's a chemical weathering of that limestone. The slightly acidic rain eats away at the limestone and carries it away as ions. That's where it maybe is a little bit trickier to picture. Like if I say, take a rock and we break it into pieces like this, the stream, I don't think it's a big leap of faith to say that, yeah, if some small bits, like some sand and some clay out of this goes into the river, those bits get carried downstream. We know that. What's a little harder to picture, because you can't see it, is that same thing happens with ions. So picture this being like the top of the rock layer there at whatever I said it was called, sorry, Clark's Reservation State Park. Water hits this, and dissolving takes the limestone and breaks it into the ions that make it up. You can do this with salt. This example's in your book. This is salt water, and I think I showed you this in the sedimentary lab already. This is salt water I made for a lab for my high school students. I just took salt and put it in the water and stirred it. That's salt water, right? You can picture that happening. You know what dissolving is. You've probably made Kool-Aid. We'll leave that sitting here and let the water evaporate away, and then it reforms the original salt. I mean, it looks different, but it's the same stuff. So picture, if you will, that happening with limestone, calcium carbonate. The water picks up those ions, and as it flows, it carries them downstream to eventually somewhere maybe form fresh deposits. In fact, I'm going to pause for another picture. This one is from, I just went on this field trip this summer, an earth science teacher field trip. This is the youngest rock, purported to be the youngest rock in New York State, because it's limestone-rich water underground. That water's coming through, flowing through, and dissolving away limestone. It gets to the surface, and as it evaporates or as it reacts with the atmosphere, it dumps those back into the solid form, kind of like this beaker that I just showed you. So there's like the whole picture of it. It dissolves in one place and it ends up in another place. Weathering, it breaks down in one place and ends up in another place. You're never like gaining or getting rid of anything in that process. You're really just moving it around in different ways. I guess that's kind of the big picture here, right? We're taking your surface, we're beating it up and moving it around and just dropping it somewhere else. Nothing's disappearing. Nothing's ceasing to exist. So take Clark's Reservation State Park, have the water flow in there. It picks up those calcium carbonate ions, right? Breaks it down and can carry it through into streams and bring it elsewhere. Which is like why the ocean is salty too. I may have mentioned this. If I point to the Salmon River over there and I say, there's salt water there, you're going to say, no, it's fresh water. And you're right, it is fresh water. But if upstream at any point, there's those ions that can dissolve, that's going to be flowing. Now it's extremely weak solution. So yes, we can say it's freshwater, but have that flow into Lake Ontario, out the St. Lawrence River to the ocean. That's where it drops off all of those ions essentially, and then the water evaporates and comes on back. That's why I threw this like water cycle on here. The water cycle is really what drives this whole thing. The energy from the sun drives the whole thing, drives the water cycle, and with the atmosphere continues the cycle of beating up rock and carrying it and dropping it off. All right, there's other forms too. Your textbook goes into some other forms. I don't think I necessarily want to get super like specific and Nancy on the specifics. I mean, this section just talks about the calcium carbonate and the water. This is pretty good right here. Check that out. But I think there's like some more. We don't have to get into like the real specifics here for this course at our level. Just keep in mind that that those are forms of chemical weathering. One other thing I wanted to mention today, we're going to have to do streams separately, right? That was one of the things in this book, in this chapter, weathering sediments and soil. So sediment is going to fall in with streams. And then also with segment 4, I've got chapter 14, streams and floods. So we're going to be coming back on some of these ideas, right? But since it lives in this world a little bit, as a stream flows, it's going to be beating up on sediments. So this right here, we're going to call abrasion. Now, through the years, from like campus westward over towards where I live in Sterling, there's many, many, many cobble beaches. So, I mean, if you're a campus student, go down there and check it out safely one of these days. Where the cobbles have been, and if it's a day where the waves are up a little bit, you can hear the cobbles rolling around with the waves and banging into each other. And what that's going to do is knock all the corners off of the rocks fairly quickly and make them rounder and smoother. Now, these are bricks. These are not like rocks, right? But I've collected them through the years because everybody knows what a brick is. I think it's a pretty easy way to like demonstrate that you can go from this through this process of abrasion, making it rounder and smoother and rounder and smoother and rounder and smoother. One of the experiments I do with the high school kids is to do that with sugar cubes, put them into a jar and shake them, and then get the mass. And if you do it for a minute and get the mass, and you do that for like 10 minutes, 15 minutes, you see that it weathers most quickly at the beginning. There's the most surface area. There's the sharpest corners. Those are the easiest things to wear off. And then that rate of weathering slows as the rock gets smaller. So we'll take another peek at this diagram when we get to rivers. But let's just say that, like, since we're talking about weathering, I don't want to skip abrasion. You know what I mean? We've got the bouncing of rocks, sliding, rolling. We'll talk about the specifics on here. But as this happens, and as sand is flowing over it, or other sediments, that acts to round off these particles as they go, like a rock tumbler, right? It's kind of a misconception that water is the thing that does this. You can take fresh, clean water and run it over a rock all you want. It's not really what does this abrasion process. It's more of the rocks banging into each other, or some of this bed load or suspended load grinding into the rocks like a sandblaster through time. All right. Thanks for listening to me babble about weathering. That's all I got for that. Let's just make sure we didn't skip anything out of the book. They go through mechanical and physical. Check this out again. I won't be cracking heads too hard on one new one there, salt wedging. I don't have any photos of that. Check that out. I won't go too hard on like specific types of chemical weathering. Keep the broad themes in mind, and you'll be fine. And then we'll pick up with the rest of this with the next video. All right. Thanks, everybody. So long for now.